This is Group 11 from the Vishwakarma Institute of Technology, and we'll be presenting the topic virtual memory. In this video, the topics we'll be covering are what is virtual memory's importance in modern computers, working of virtual memory, techniques of virtual memory, advantages and limitations. Coming to the introduction of what is virtual memory is a computer system memory management technique that allows a computer to use more memory than it physically has available. It works by temporarily transferring data from the computer's RAM to the hard drive or solid state drive when the RAM is full. The computer can then retrieve the data from the hard drive or SSD when needed, which makes it appear as if the computer has more memory than it actually does.
Importance in modern computers, it allows computer to run more applications simultaneously than it could with physical memory alone. Increase effective memory, efficient memory allocation allows the computer to use more memory than physically available in the system's RAM, make more efficient use of available system resources. Virtual memory provides a mechanism for protecting memory from unauthorized access, allows large programs to run on systems with limited physical memory. This is particularly important for complex applications like video editing softwares or games which require a lot of memory to run smoothly, freeing applications from having to compete for shared memory space and allowing multiple applications to run at the same time, allowing core processes to share memory between libraries, which consist of written code that provides the foundation for a program's operations, improving security by isolating and segmenting where the computer stores information, improving efficiency and speed by allowing more processes to sit in virtual memory, lowering the cost of computer system as you find the right amount of main memory and virtual memory, increasing the amount of memory available by working outside the limit of a computer's physical main memory space, optimizing center person unit usage.
Now we get to working of virtual memory. Virtual memory is a technique used by modern computer operating systems to extend the amount of available memory beyond the physical memory RAM installed in the system. Here's how virtual memory works in brief. First, the operating system divides the virtual memory spaces into pages, which are typically 4 KB in size. When a process requests memory, the operating system checks if the requested page is presented in physical memory. If the page is present, the process can access it immediately. If the page is not present, the operating system retrieves it from the hard disk and brings it to the physical memory. If physical memory is full and there are no available pages to be used, the operating system uses a page replacement algorithm to search a page to be evicted from physical memory and return back to the hard disk. The algorithm aims to choose the page that is least likely to be used again in the near future, thus minimizing the impact on the process's performance. When a process tries to access a page that has been evicted from the physical memory, a page fault occurs. The operating system then retrieves the required page from the hard disk and brings it to the physical memory. Virtual memory allows processors to use more memory than the physical memory available in the system. However, the use of virtual memory incurs some performance overhead due to the time required to fetch pages from the hard disk and the page replacement algorithms processing time. Virtual memory also allows for memory protection by assigning each process its virtual memory space, preventing it from accessing memory allocated to other processes.
Now, talking about the techniques, the first technique is tagging. Tagging is a memory management technique in which a process is divided into smaller fixed size chunks called pages. These pages are stored in the main memory or secondary memory. When a process requires a page that is not currently in the main memory, the operating system loads the page from the secondary memory into main memory, as you can see in the diagram. Uh, Talking about the swapping technique, swapping is a technique in which the process is temporarily moved from the main memory to the secondary memory, that is hard disk. When there is no enough space available in the main memory, to hold all the processes that are running simultaneously. This technique is used when the operating system needs to free the memory space for the other processes. Both the swapping and pegging are used by the operating system to optimize the usage of memory resources and improve the performance of the system.
Now coming up on the differences, pegging. More processes can be stored in the main memory using this strategy. Swapping reduces the number of processes in the main memory. A non-contiguous memory management is allowed by pegging, while swapping is possible without the use of any memory management techniques. Pegging is a memory management technique in which the computer stores and retrieves the data for uses in the main memory from secondary storage, while swapping is a technique for temporarily removing inactive applications from the computer system's main memory. Pegging is more adaptable because it allows for the relocation of process pages. Swapping is less flexible because the entire operation goes back and forth between the main memory and the backstore. Pegging occurs when a portion of a process is written to disk. When the entire operation is transferred to the disk, this is known as swapping. In pegging, for favor workloads, the pegging technique is used. For vast workloads, swapping technique is used. This methods allows a process memory address to be non-contiguous. Multiple processes can operate in parallel in the operating system with the help of swapping. This technique helps to implement virtual memory, while swapping helps the CPU to access processes faster.
We now move on to the advantages and limitations between the two. So, when we talk about the advantages, we have increased memory capacity. However, at the same time, you may also experience slower performance. But also, the system performance can be upgraded. How? Because the paging and swapping techniques allow the system to allow to open multiple tabs at the same time. But because of that, you can also experience wear and tear on the hard drive. You can multitask, but at the same time the power consumption is more. It's cost effective, but then you have limited space. The scalability and more efficient memory usage are comparatively much better when we talk about the advantages as compared with the fragmentation that you have. We now come to the conclusion of our topic. The first one, virtual memory is a technique used by the operating system to simulate more memory than what is physically available in a system. It uses the combination of physical memory, such as storage devices, you can say a hard disk or a SSD, to store multiple programs and data. It also allows multiple programs to run simultaneously without requiring excessive amount of physical memory. Virtual memory provides a layer of protection between programs, preventing them from accessing memory that they are not authorized to access. Virtual memory can also improve the system's overall stability by preventing programs from crashing. It also requires more power than physical memory, which can be a concern for portable devices with a limited battery life. Virtual memory, in conclusion, if we say virtual memory is an essential technique used in modern computing. There are obviously certain drawbacks of it, but we should focus on the more optimal system performance and longevity. Thank you.